Welcome you all. In this session we are going to discuss about looping, counting and indexing. Expected outcome: after successful completion of this session, the student would able to explain the concept of looping, counting and indexing in 8085 microprocessor. Looping: the programming technique used to instruct the microprocessor to repeat a task is called looping. The task is accomplished by using a jump instruction. So if you want to repeat a task again and again, we can go for looping that particular task, which is similar to if statement. Classification of loops: it may be a continuous loop or an unconditional loop. uh, that is, if it is a conditional one, it will be continuous. Unconditional means it won't stop, it goes on. Okay, so that's so continuous. So continuous loop: repeat a task continuously. A continuous loop is set up by using an unconditional jump instruction. If you are not giving any condition at the jump statement, this process repeatedly done, there won't be any ending for that. A program with continuous loop does not stop. That is what I mean. Repeating the task until the system is resetted. So now the second one is conditional looping. So here, that is, a conditional looping is set up by conditional jump instruction. So once the condition is satisfied, the loop will be automatically stopped. So these instructions check the flag Z, C, Y, P and S, that is sign 0, carry, auxiliary carry and parity flag, and repeat the task until the condition is satisfied. Conditional loop and counter. A counter is a typical application of conditional loop. A microprocessor needs a counter flag to accomplish the looping task. A counter is set up by loading an appropriate count in the register. Counting is performed by either increment or decrement the counter. Loop is set up by conditional jump instruction. End of counting is indicated by the flag. Indexing: pointing of an object or pointing something, we call them as indexing. Data bytes are stored in memory locations and those data bytes are referred by their memory locations. This is what we mean as indexing. Say for example, steps to add 10 bytes of data stored in memory location, starting data given location and display the sum. So the microprocessor needs to add all the data. A count, it needs to count 10 times because it is 10 bytes, so 10 data bytes. An index or memory pointer to locate where the data byte are stored. To transfer the data from memory location to microprocessor or to ALU to next it need to perform addition. The register of temporary storage is a partial answer. For again the same process need to be repeated, so until the counts value 10. So initially I'm storing the count as 10. So what I need to do is, here the decrement operation goes on for each addition. A decrementation is done, so I need to check the counter whether it becomes 0 or not. So once it becomes 0, the 0 flag will be set. So with the help of that I can stop it, show the result. So now for indexing, here comes a here we have a flowchart. So starting initializing session. So here we are going to initialize the counter, or we are, what are the registers you need to initialize, we can initialize here. Processing selection: next the processing is done, that is some operation we need to perform. Loop control selection: so now it need to check the condition whether loop is over or not. It's a conditional loop. So if the condition is satisfied, then the result will be stored, or it stops execution. So if suppose, let us consider the other way, that is, if the condition is not satisfied, then the same process need to repeat again and again, so until the certain condition is attained. So this is what we call it as a conditional loop. So for for an unconditional loop, you need not go for this condition. Just once you come here, without checking this instruction, directly it can be moved to the point where it need to repeat it again. So directly you can go. So you need not record this condition. That is the difference between a conditional loop and an unconditional loop. So indexing, the initialization session established the starting value of loop counters for counting how many times the loop to be executed. So initially we need to say how many times it need. Say for example, if for the previous case, and I have illustrated an example for adding 10 bytes, right? There I told I need to set a counter as 10 and a decrementation operation need to be performed. So similarly here for in the installation session, what I need to do is I need to set the count values. The actual data manipulation occurs in the processing session. This is the session which does the work. The loop control session updates the counter pointers and the next iteration. The results session will analyze and store the result. Thank you.